So we're reviewing for the square roots test. Now, 7 squared in the same way. Square root of 81 is 9. Square root of 100 is 10. So when we look at the square root of 96, it's closer to 10. Square root of 25 is 5. Square root of 36 is 6. 28 is closer to 25, so the square root of 28 is closer to 5. The negative square root of 121, well, 121 is perfect square. It's 11, so the negative square root of 121 is negative 11. The positive square root of 144 is positive 12. Again, it's a perfect square, nothing left underneath it. Do not leave the square root in your answer. 300 is not a perfect square, but we can do a little factor tree. To multiply and get 300, most people probably think of either 3 times 100 or 30 times 10. Either one would work. If you go with the 100, 10 times 10 is 100, 5 times 2 is 10, 5 times 2 again is 10. So instead of square root of 300, we can write 2 times 2 times 5 times 5 times 3. We're looking for pairs of the same factor. So square root of 2 times 2 is 2, square root of 5 times 5 is 5, and then we have that 3 left underneath the square root. 2 times 5 in front is 10, so 10 square root 3 is your final answer. Some people may have thought of 100 times 3 and realized 100 is a perfect square, and so you can get there a little bit quicker if you realize that. Square root of 100 is 10, so 10 square root 3 is your answer. So same answer, either method. Number 7, it doesn't matter if you know what 17 times 17 is. The square root of 17 times the square root of 17 is just 17. Now it happens to be 289, but it really doesn't matter if you know that. Square root of a number times the square root of the same number is that number, no square root. So again, happens to be 289, but it really doesn't matter if you know that. Number 8, 128 is an even number, so it'll divide by 2. So 2 goes into 12 6 times. To multiply, you get 12, subtract, bring down the 8. And 2 goes into 8 4 times. So 2 times 64 is 128. And then for the 64, you can do 8 times 8. And then for the 8, 4 times 2. And then for the 4 is 2 times 2. So 128, or the square root of 128, can be rewritten as 2 times 2 times 2 times 2 until you have 7 2's. So the square root of 2 times 2 times 2 times 2 times 2 times 2 times 2. Now you're looking for pairs of the same factor. Square root of 2 times 2 is 2. Square root of 2 times 2 again is 2. Square root of 2 times 2 is 2. And that other 2 is left underneath the radical. Multiply the numbers in front. 2 times 2 is 4 times 2 is 8. So 8 square root 2. If you notice that 64 is a perfect square, you can get there just a little bit quicker. 5 square roots of 7 plus 8 square roots of 7, treat those as like radicals. That's 13 square roots of 7. Much like 5x plus 8x is 13x. Number 10, 2 square root 6 minus 5 square root 6 is negative 3 square root 6. They're like radicals, you can add or subtract them. Just like 2x minus 5x is negative 3x. They're not like radicals yet, so work with the 20. Do a factor tree on the 20. To multiply and get 20, you can do 4 times 5. 4 is 2 times 2. So instead of square root 20, we can have square root of 2 times 2 times 5. So we have 3 times square root of 2 times 2 times 5. And then we still have that plus 8 square root 5. Square root of 2 times 2 is 2. So we have 3 times 2 times the square root of 5 plus 8 square root of 5. 3 times 2 gives us 6 square roots of 5. So 6 square root 5 plus 8 square root 5. They're like radicals. We can add them together and get 14 square root 5. Number 12, multiply the numbers in front. 5 times 3 is 15. And then 32 times 2 is 64. So 15 times the square root of 64. 64 happens to be a perfect square. Square root of 64 is 8, because 8 times 8 is 64. Then multiply 15 times 8. 8 times 5 is 40, carrying a 4. 8 times 1 is 8, plus the 4 is 12. So 120 is your final answer. We cannot leave an irrational number in the denominator, so multiply the top and the bottom by square root 11. On the top, you'll have 4 times square root 3 times square root 11 is square root 33. On the bottom, square root 11 times square root 11 is 11. So final answer, 4 square root 33 over 11. The 4 and the 11 have no common factors, so it will not simplify anymore. Square root of 100 is 10. When you're taking the square root of a variable with an exponent, it's like dividing by 2. 2 goes into 6 3 times, no remainder, so we'll have x cubed. And then 2 goes into the 16 8 times, no remainder, so we'll have y to the 8th. If you start with an even exponent and end with an odd exponent, you need absolute value, because we're trying to make it to be the positive square root of all that stuff. So put the absolute value around the x cubed, and so that's our final answer. 10 times the absolute value of x cubed, and then times y to the 8th. (15) 32 is not a perfect square, so do a factor tree. To multiply and get 32, most people are probably thinking 4 times 8. To get 4, 2 times 2. To get 8, 4 times 2. And then to get 4, 2 times 2. So we have 1, 2, 3, 4, 5 factors of 2. So instead of 32, or square root of 32, we can write 2 times 2 times 2 times 2 times 2. Looking for pairs of the same factor. Square root of 2 times 2 is 2. Square root of 2 times 2 again is 2. And then that other 2 is left underneath the radical. Square root of x to the 8th, it's like dividing by 2. 2 goes into 8 4 times, no remainder. So we have x to the 4th. And then 2 goes into the 16 8 times, no remainder. So we'll have y to the 8th. Now we'll multiply that 2 times 2 in front. So our final answer here will be 4 x to the 4th, y to the 8th, square root of 2. We started with even, ended with even. We do not need any absolute value. All right, if you do 30 times 3, you get 90. So we can go ahead and combine the negative 1 square root of 90 plus the 5 square root of 90. So if we add those together, we get 4 square roots of 90. Now, square roots of 10 and square roots of 90 are not like radicals, so we need to go to a factor tree with the 90. All right, so next line, 4 square root 10 plus 4 square root 90. Now doing a factor tree with the 90, to multiply and get 90, you can do 9 times 10. To multiply and get 9, you can do 3 times 3. To multiply and get 10, you can do 5 times 2. So instead of the square root of 90, we can write 3 times 3 times 5 times 2. Looking for pairs of the same factor. So the square root of 3 times 3 gives us 3. So 4 square root 10 plus 4 times 3 square root 5 times 2 will give us 10. 4 times 3, that's 12 square roots of 10 plus the 4 square roots of 10. Now that they're like radicals, we can combine them and get 16 square roots of 10 for our final answer. (17) Square root of a fraction is the square root of the numerator over the square root of the denominator. Square root of 100 is 10. Square root of 121 is 11. So final answer, 10 over 11. So hopefully this video has helped you prepare for the test.